Okay, so this is the third video in the series about rules for exponents. So we're going to cover that third rule, which is what is called the power rule. Okay, so we're going to look at an example. So if I look at the example of, say, that I had x squared raised to the fifth power. So remember, this 5 here outside, that's saying take all this stuff and repeat it 5 times. So it's all this stuff being multiplied times itself 5 times. So it would be x squared, that's once, times another x squared, that's 2, times another x squared, that's 3, times, oops, jump to the next page here, times another x squared, that's 4, times another x squared, that's 5. And then remember, x squared is just x times x. Or if you think about it, now I have, I can use the product rule, right? So I have x to a bunch of different powers. So to work that out, it's going to be x to the 2 plus 2 plus 2 plus 2 plus 2 more. So you end up with x to the 10th power. So if you compare 2 and 5, right? If I multiplied 2 times 5, I would get 10. And that's all the power rule says. So the power rule says that x to the a raised to the b power is actually x to the ab power. And so let's try a couple more. Let's try another example here. So, and usually the direction on these problems is simplify. So simplify y to the 7th to the 5th. So all I'm going to do here is I am going to multiply 7 times 5. So we've got y to the 35th, right? Because 7 times 5 is 35. I'm really sorry for all the construction noises you hear, but they're building stuff outside of my office door, so, or outside of my office window. So if you hear the construction in the background, that's what's going on there. Let's look at something else. So let's look at x to the 3rd y squared all raised to the 4th power. So again, if I write that out, I'm saying I have an x cubed y squared 4 times. So x cubed y squared, another x cubed y squared, another x cubed y squared, another x cubed y squared. Right, so there's 4 of them. And then remember that in between here, in between the x cubed and the y squared is multiplication, which means I can rearrange the order, right? When we multiply things, we can rearrange the order of stuff. We do this all the time, right? Like if I want to multiply 2 times 9 times 5, I might say, oh, let me do 2 times 5 first, that's 10, and then 10 times 9 is 90. So we rearrange terms all the time. So in this case, I'm going to put all the x's together since everything's multiplied. So x cubed times x cubed times x cubed times x cubed. And I'm going to put all the y's together. So y squared times y squared times y squared times y squared. And so this becomes, I have x to the 3 plus 3 plus 3 plus 3. And then y to the 2 plus 2 plus 2 plus 2, right? Using that product rule from 2 videos ago. And now this becomes x to the 12th, y to the 8th. And if you notice, I could have actually just done 4 times 3 and 4 times 2. So as long as everything inside the parentheses here is all multiplied together, you can distribute the exponent. So that's an important note, so we're going to write it down. Can distribute the exponent and multiply only if the inside is multiplied or divided. You could do it with division too. You cannot do it with addition or subtraction. Cannot. That's a terrible looking N. Let me rewrite that. Cannot do it for addition or subtraction. And this is going to become important in the near future. Okay, so in a couple of videos from now, we're going to talk about these things called polynomials. And because of that, you cannot do it for those types of problems. But for addition or for multiplication or division, you can. So why don't we look at a division one? And we'll look at a couple different things here. So simplify. So if I had x to the 4th over y to the 7th, all raised to the 3rd power. So in there, the only thing that's inside the parentheses here is division. So I can take this 3 and I can multiply it times each of these. So we'd end up with x to the 12th over y to the 21st. Let's try another one. So what about negative 4 x y cubed all squared? Okay, so this one, the 2, it's got to go to each of the pieces. The first piece is the negative 4. The second piece is the x. This piece is the 3. So the way to write this, so you can think of this as this is negative 4 all to the first power. Just like this is x to the first power. So when I distribute this, we would get negative 4, 1 times 2 is 2 to the second power. X, 1 times 2 is 2. Y, 3 times 2 is 6. And then negative 4 squared is 16. So 16x squared y to the 6th. We can do a similar type thing if I had minus, let's say, x to the 3rd, y to the 5th, z to the 6th, all raised to the 3rd power. Okay, so again, you want to think about the fact that really this negative 1 is really, this negative that's right here, it's really saying it's a negative 1. And so this cube has to go onto the negative 1. It's got to go times that 3, times that 5, and times that 6. So we're going to have negative 1 cubed, x to the 3 times 3, y to the 5 times 3, z to the 6 times 3. So we're going to have negative 1 cubed is negative 1, x to the 6th, oops, not 6, 3 times 3 is 9, x to the 9th, y to the 15th, z to the 18th. And remember, I don't have to write that negative. I don't have to write the 1 with the negative, so I could just write this as minus x to the 9th, y to the 15th, z to the 18th. And we can even have multiple of these. So I could have something like this, like minus 2x squared y cubed z cubed all to the 2nd power times minus x to the 4th y squared z to the 3rd power. Actually, I probably should. Let me see if I can move this problem. Give myself some more room. Well, that is a weird looking move. Let's see. Okay. So let's see. Oh, that rotates it. That shrinks it. Oh, there we go. Perfect. Okay. I'm just going to do it up here. Okay, so first thing I'm going to do is I'm going to take this 2. It's going to go to the negative 2, to that, to the x part, to the y part, to the z part, right? So we're going to get negative 2 squared, x to the 4th, y to the 6th, z to the 6th. I have to do the same thing over here. This 3's got to go to the negative. It's got to go to the x, to the y, and to the z. So we're going to get times negative 1 cubed times x to the 12th, y to the 6th. And that z didn't have a power, so remember it's always a 1, so it would be z cubed. Now the thing I'm going to do is I'm going to figure out these number parts. So negative 2 squared is 4. So I have 4, x to the 4th, y to the 6th, z to the 6th. And negative 1 cubed is just negative 1. So I have negative 1, x to the 12th, y to the 6th, z to the 3rd. And then I'm going to put the pieces that go together next to each other. So we're going to have the 4 and the negative 1 next to each other. And then we'll put the x pieces next to each other. So x to the 4th, x to the 12th. Put the y pieces next to each other, y to the 6th, y to the 6th. And I'll put the z pieces together. So z to the 6th, z cubed. And if I do that, I end up with negative 4. I can now add the exponents on the x's, right? So the exponent on the first x here is a 4. The exponent on the second x is a 12. 4 plus 12 is 16. So we have x to the 16th. I can again add the 6 here and the 6 here because they're both y's on the bottom. And so if I do that, I end up with y to the 12th. Same thing for the z's, 6 and 3 is 9, so we end up with z to the 9th. So that's the final answer for that one.